Hey everyone, so much like the last video, I'm going to start this one off by talking about the transformations to the function. So to start off with, it's got a negative at the front, which is a reflection in the x-axis. So this is going to be a cos graph, but it's going to be turned upside down. It's got a dilation from the x-axis by a factor of 4, so that means that the amplitude is also 4. I'll write that off on the side right now. It is dilated by a factor of 1/3 from the y-axis. So what that actually means is it's 1/3 as wide as it should normally be. But that's used in our calculation for the period. So again, it's a sine or cos function, so we do 2 pi on n. So that's 2 pi on 3, which doesn't simplify. So this has a period of 2 pi on 3, and again, this is using a really ideal domain for this particular function. And also we have this part here, which is the horizontal translation, and this here moves the graph pi on 6 units to the left. So what I'm going to do is I'm going to mark the 4 and -4, those are going to be important values on the y-axis, and it's going to start negative pi on 6, and we have to go through to pi on 2, so that's pi on 6 and then 2 pi on 6, which is the same as pi on 3. And then we've got 3 pi on 6, which is the same as pi on 2. So that's actually going to be all that I actually need for this particular graph. And it's a negative cos function, so normally it would start down the bottom here, and it would sort of go up and back down. But we're moving it pi on 6 to the left, so it's going to start right here. Okay, it finishes 2 pi on 3 units later, and if we add 2 pi on 3 on to negative pi on 6, it actually takes us right over here to pi on 2, so that's quite convenient. Okay, and then we would have the maximum exactly halfway in between these 2 points, given that these are the minimums. So the maximum should be at pi on 6. And then it's going to pass through the x-axis, or the theta axis, I guess you could call it, exactly halfway between those values as well. So it's going to pass through there and there. And finally I can sketch it, so starting here and being nice and careful to get a nice smooth curve. I'd get something like that. So again, like if we look at the, well, if we forget about this part here, this graph actually looks like it's just a normal sine function, even though, you know, it is actually a cos function, and it just happens to be the way with this particular graph. So again, it's been translated by that perfect amount to make it so it looks like really the opposite of what it should be. Anyway, we'll leave that one there and pick up with the next example.